Good morning. My name is Ann Spinello, and today's lesson is going to be about word problems, many of which include positive and negative numbers. I'm one of the regular tutors from the Seeds of Literacy program. And there we go. The problems that are going to be in this presentation are not from any of the Seeds of Literacy packets. They're problems that I found in other locations. I thought it would be helpful to practice both word problems and kind of reinforce our skills working with our positive and negative numbers. But if you would like additional practice for word problems, Seeds had two packets that you might want to look into. The Steck-Vaughan one that's from the Mathematics Skills book, and then also the Problem Solving and Application packet. And Shauna, before I go too far, I just want to make sure, can you actually see my screen?
Yes, I can.
Okay, because on my end, it's showing that you're looking at a black square, but so long as you can actually see my screen, it does that sometimes. Okay, before we get too far, I wanted to show you a couple of the note pages. These come from the two packets I was just talking about. Really helpful. If you had those packets, I just wanted to make the recommendation that you flip through and you find these are some key words that are used in word problems that help you understand, should I be adding, subtracting, multiplying, or dividing? I just wanted to say that if I were a student, I would cut these sections out and actually keep them in some note pages. And this is the note section from the Steck-Vaughan packet. Same thing, just some helpful hints so to help you guide you to work these problems. Before I get started, I want to quickly review some of the vocabulary terms we've been talking about in the last couple of weeks to do with positive and negative numbers. First of all, a positive number is any number greater than 0. Positive numbers can be written these three ways: positive 18, or positive 18 with parentheses. Negative numbers, that's any number less than 0, actually to the left of 0 on the number line. You will see negative numbers written these two ways, just a straight negative 18 or in parentheses. Another word I'm going to be using quite a bit. An algorithm is just a set of rules to perform a procedure. For instance, if you know how to do long division, the steps to long division would be considered an algorithm. If you know how to add fractions, the steps or the process to add fractions, that's also an algorithm. And then another absolute value. That's talking about the distance any number is away from 0. When we write our algorithms to help us do the different operations for positive and negative integers, it's going to be a good term in order for us to describe what needs to be done. So for instance, we've got two numbers, positive 3, and I can't see the other one, and negative 12. So if someone were to ask which is the larger number is actually positive 3 because that's farther to the right on the number line. But sometimes we don't actually want to know which number is larger. We want to know which number has a greater absolute value, which is farther from 0. Well, negative 12 is farther from 0, so it has the greater absolute value. Before I go on, I'm going to try one more thing so that I can hopefully, there we go. And it didn't work. I still can't see what you're saying, but that's okay. We'll continue. Okay, the algorithms that we talked about a couple of weeks ago, I just want to review them quickly because we'll be using them today. When we are adding, if the two numbers have the same sign, we're going to add the absolute values. If the two numbers have different signs, we're going to subtract the absolute values. And the answer is going to take the sign of the greater absolute value. We're going to practice that a little bit. For instance, in this group, all of the problems were adding two numbers with the same sign. So this is a positive plus a positive, this is a negative plus a negative. And whenever we have the same signs and we're adding, we add the absolute values and we're going to keep the sign. So Tashana, the first problem is positive 2 plus positive 8. Will our answer be positive or negative?
Same sign. It's going to be positive.
Nice. Oh, let's see. Is it going to let me do this? There we go. And it was positive 10 when we add those numbers. Okay. So negative 2 plus negative 8, they have the same sign. So what's that answer going to be?
It's going to be positive.
It's very tricky because in a minute we're going to...
Hold on.
Okay.
It's going to be negative because they both got the same sign. So it's negative 10.
And it's really confusing because the addition algorithm is very different than the multiplication algorithm. They're almost opposites of each other. And so this is the most challenging algorithm to kind of internalize. Okay, so you're right, it is negative 10. How about positive 8 plus positive 12? What's that going to be?
Positive 20.
Nice. How about negative 8 plus negative 12?
Negative 20.
Nice. Okay, now on this screen, all of the problems, all of the numbers that we're adding, they have different signs. One's always a positive and one's a negative. So anytime our signs are different, we're going to wind up subtracting those absolute values, which feels very strange. And our answer is going to take the sign of the largest absolute value. So not of the largest number, but of the term that is the farthest from 0. So let's start with that. With positive 2 plus negative 8, will this answer be a positive or a negative?
It'll be a positive 10.
But our answer here, it says answer is going to take the sign of the larger absolute value.
Negative 8. I'm sorry. I mean negative 10.
Okay, it's going to be a negative. Okay, now we have to do the next step. We have to subtract those absolute values. It's an addition problem, but we're actually going to subtract the 8 and the 2.
A negative 6.
Negative 6 is it. Perfect. Okay, so the next one, negative 2 plus positive 8. So again, our signs are different.
Positive 6.
Okay, so it is going to be a positive because the positive 8 is farther from 0. And you're right, when we subtract the 8 and the 2, it's going to be a positive 6. Okay, the next one, positive 8 plus negative 12. What's our answer going to be, a positive or a negative?
It's going to be a negative.
Negative is correct. So now when we subtract those absolute values, what's that going to be?
Is it negative 4?
Nice job. Now, how about negative 8 plus positive 12? What's that answer going to be?
A positive 4.
Perfect. Nice job. Okay. When we subtract, we're going to always turn subtraction problems into an addition problem by adding the opposite. So that's our algorithm. Oh, and then once we've done that, we're going to use the addition algorithm to solve the problem. Okay, let's see here. It's acting up today. There we go. So let's try practicing some. So we're going to add the opposite is our algorithm. So we have a subtraction problem here. We need to practice rewriting that, adding the opposite of a positive 8. And so remember, the opposite of a number is the same distance on the other side of 0 on the number line. So Tashana, do you remember how to rewrite this first problem, positive 12 minus positive 8, rewrite that adding the opposite.
Would it be negative 12 plus negative 8?
Nope. Whenever we're rewriting or using add the opposite, the first term stays the same. It's really important that your starting point never change. So,
Okay, so it'd be positive 12, take away negative 8.
you're really close. You forgot, though, that we are writing an addition problem.
So positive 12 plus negative 8.
That is exactly it. And that's really tricky to do. That's why I wanted to practice some of these. So now we have to use our addition algorithm, which is, we've got the same sign. I'm sorry, we've got different signs. So the answer is going to take the sign of the larger absolute value, and we're going to subtract those terms. So do you know what this answer is going to be?
Different signs of share and take side of it. Okay, so it would be negative 5 plus positive 7. Or
Oh, no. We're still on. See, the thing that's
oh,
strange.
up here.
Yeah, we're still
Oh,
on this one. My screen is
okay.
showing something completely different, but go ahead. We're on positive 12 plus negative 8. So what's that answer going to be?
If you 12. It's gonna be positive 4.
You're awesome. That's great. If we can make our screen show that. There we go. Okay, the next one, negative 5 minus a negative 7. It's a subtraction problem, so the first thing we need to do is rewrite that problem, keeping the starting point the same and adding the opposite of a negative 7. So help me rewrite that, Tashana.
So it's gonna be negative 5 plus positive 7.
Perfect. And so now we can solve that one using the addition algorithm. Our signs are different. So what's the answer going to be?
7. A positive 2.
You are doing great. What about negative 4 minus a negative 2? Help me rewrite that one, adding the opposite.
Negative 4 plus positive 2.
Is exactly correct. What's the answer to negative 4 plus positive 2?
Positive 2.
Remember, they're different signs, so the answer is going to keep the sign of the larger absolute
negative
value.
2.
Negative 2 is correct. And how about positive 2 minus positive 4? Help me rewrite that.
It's gonna be positive 2 plus negative 4.
Nice. And so now we've got different signs again. Help me add those two numbers.
It's gonna be negative 4. Negative 2.
Negative 2 is correct. Nice job. Okay, we're going to practice a few more. Go ahead and help me add the opposite. It's positive 12 minus negative 8.
Positive 12 plus positive 8.
Nice job. We have the same signs this time. What's that going to equal?
A positive 20.
Perfect. How about negative 5 minus a positive 7? Help me rewrite that one, adding the opposite.
So it'll be a negative 5 plus negative 7.
It will. And so what does that equal?
A positive 2.
Okay.
Wait, a negative 2.
Do it again.
5, 7, 8, 9, 10, 11, 12, 13, 14. A negative 14.
You are really close. It is going to be a negative, but when we add the 5 and the 7, it doesn't equal 14.
12. I'm
That's
sorry.
it. Nope, I get it. Negative 12. Okay, the next problem is negative 4 minus a positive 2. Help me rewrite that one.
Negative 4 plus negative 2.
That's correct. And what does that equal?
4, 5, 6. Positive 6. Negative 6. Negative 6.
Negative 6 is correct. It's
Negative
opposite of that multiplication algorithm, but you've got it. Help me rewrite positive 2 minus a negative 4.
Positive 2 plus positive 4.
What's that equal?
4, 5, 6. Positive 6.
Perfect. Okay. Multiplying and dividing, the rules for multiplying and dividing positive and negative numbers are much more simple. If the signs are the same, the answer is positive, and you're just going to multiply it like normal. If the signs are different, the answer has to be negative, and you're just going to multiply or divide like normal. So let's practice these. 5 times 7, what does that equal?
35.
Perfect. How about negative 5? Oh, forgot to put the rules up. Negative times negative is also going to be a positive. The signs are different. Oh, okay. So so you said it was going to be 35. Positive 35. Perfect. Now we have negative 5 times by negative 7. So those signs are the same. So what's my answer going to be? Positive or negative?
A positive.
Good. It's the opposite of when we were adding, but this is going to be a positive what?
35.
That's it. How about 8 times 9? What's that going to equal?
52 is gonna be 52.
Did you say
Wait,
52?
72.
72 is correct. And how about negative 8 times by negative 9? What's that going to be?
Positive 72.
You're awesome. And it sounds like maybe, were you using that nines trick to solve those?
Yes.
I thought so. I didn't know who was going to pop on. And so I went ahead and I included the nines trick again, but you did very well. When you were saying 52, I could just hear you folding down those fingers and recounting. So nice job using that trick. Okay, so now we're going to do some more multiplication practice. 3 times by negative 9. The signs are different this time. So when we have a negative times by a positive, answer is going to have to be, is it going to do it?
Negative.
Well, the answer is a negative. There we go. Okay, so now let's do positive 3 times by negative 9.
Negative 27.
Negative 27 is correct. Boy, it is really acting up this morning. There we go. Negative 27 is correct. How about negative 3 times by positive 9? What's that going to be?
Oh. Negative 27.
Perfect. How about positive 7 times by negative 5?
Negative 35.
Is correct. How about negative 7 times by positive 5?
Negative 35.
And that's it. Okay. Sometimes we have to multiply more than 2 terms or more than 2 numbers together. And so remember, when we do this, we're going to count the negative signs in the problem. If we have an even number of negative signs, our answer has to be positive. If we have an odd number of negative signs, the answer has to be negative. Okay, so let's practice these again. 2 times 3 times 4 times 5. What's that going to be? I'll give you a minute to multiply this one out. It takes a while.
Okay. 20. 120.
That is correct. So it's going to be a positive 120. So now we have all the same absolute values, but this time we have one negative sign in there. So our answer, is it going to be a positive or a negative?
It's going to be a positive.
Well, we've got one negative sign and one is an odd number.
Oh,
So
it's going to be a negative 120.
That's it. How about this next one? Positive 2 times negative 3 times positive 4 times by negative 5.
It's
We've
going to
got
be
two negative signs. What's it going to be?
a positive 120.
Positive 120 is correct. How about D? Negative 2 times negative 3 times 4 times negative 5.
A negative 120.
Perfect. Negative 2 times negative 3 times negative 4 times negative 5.
Positive 120.
Nice. So now we have the exact same algorithm for dividing. So if the sign, we're going to practice some division. If the signs are the same, it's going to be a positive answer. If the signs are different, it's going to be a negative answer. So the first problem, positive 28 divided by negative 4. Is that going to be a positive or a negative answer?
That is going to be...
Signs are different. So when the signs are different, will
It's
it be a
gonna
positive or a negative? Say it again. What's the answer going to be, positive or negative?
A negative.
Negative is correct. So now 28 divided by 4 is what? Do you know that one?
7.
Correct. Let's go down here to negative 64 divided by negative 8. That answer, will it be a positive or a negative?
It's going to be a positive.
Nice. Positive what?
Positive 8.
That's it. How about negative 48 divided by negative 6? Will that be a positive or a negative?
Positive.
Nice. And what is 48 divided by 6?
8.
Correct. How about 49 divided by negative 7? What's that answer going to be, positive or negative?
It's going to be negative.
Negative. And so what's the answer going to be?
Negative 7.
That's it. Okay. Now we're going to practice some word problems. Oh, and I said order of operations. We won't be doing order of operations today. Wound up being way too many problems. Okay. So our first word problem says, a football team is at its own 25-yard line. In the next 3 plays, it loses an average of 4 yards per play. Where is the team after 3 plays? So, Tashana, you tell me, do you want to try to work it on your own and then we'll compare answers? Or do you want to go through it with me?
I can try to do it on my own.
Okay, you try to do it on your own and then we'll compare.
The next 3 plays, it loses an average of 4. Makes sense. The football team is 25 on next 3 plays. So 25. 21. 21. 21 take away. Oh shit. 20 take away 3. Is it 18?
Okay, let's go through it. Not quite.
Okay.
So, let's see if it'll advance. So the first thing I do is I write, there's not really a picture for me to draw, because ordinarily when I've got a word problem, I try like heck to draw a picture to help my brain understand. Since there's not a picture, I kind of try to write down the information that is in the word problem. So I know that I'm starting out on the 25-yard line. And then I know the next thing that happens is there are going to be 3 plays. And in each of those 3 plays, I lose an average of 4 yards per play. So we know that losing 4 yards per play is happening over and over 3 times. So what kind of a problem is this going to be, Tashana? What
A
operation?
multiplication problem.
It could be a multiplication. When I was listening to you solve it, I almost thought I heard you using repeated addition, which, by the way, absolutely works. You could have said, I'm on the 25-yard line, and then I lose 4 yards. That takes me to the 21-yard line. I lost 4 yards again, and then I lost 4 yards again. That would have worked. But another way to do that a little more quickly is to use multiplication. So what is 3 times by -4, Tashana?
-12.
Nice. And I think I had the algorithm. It is -12. So we could write this problem as 25 plus a -12. And so do you know what that answer is going to be?
13.
13 is correct. So there was the algorithm we had to use, and the answer was 13. So after 3 plays, the team is on its own 13-yard line. Nice. Let's try another problem. Together, siblings Brandon, Brooke, Trent, and Trisha owe their parents $100. We need to write a number sentence to show how much each sibling owes if they share the debt equally. And then it says, be sure to use negative numbers where appropriate. So in this case, our job is to write a number sentence to match this problem, and then we'll also go ahead and solve it. Before we get started, one of the things that commonly comes up with students is, how many siblings are in this family, Tashana?
It's
How many
4.
kids? 4 is correct. A lot of people miscounting that. Go ahead, see if you can solve this one. Siblings Brandon, Brooke, Trent, and Trisha owe their parents $100. Write a number sentence to show how much each sibling owes if they share the debt equally. Be sure to use negative numbers where appropriate. Go ahead and let me know when you've got your answer.
What is it? I can't see. Oh, sorry.
Okay, so they owe. Then they are.
Good morning, Brianna. My name is Anne, and we're in the middle of a lesson on solving word problems, but I tried to insert a lot of positive and negative numbers. Tashana is also in the room, and she likes to try to solve the problem on her own, and then we'll compare our answers in just a minute. So if you'd like to work on solving these problems as well, or you're welcome to just watch and listen. Just let me know what you'd rather do.
Okay, so if they owe her $100, then they are negative 100, right?
That's correct. Good.
And then if they do negative 100 plus positive 25, then they will be, wait, a negative 100 plus 25
Tashana,
times
I'm gonna read the
4.
problem to you again. And before I show you what work I did, I want you to take another stab at it. So we know they owe their parents $100. So that was great. It's gonna be a negative 100 because being in debt, that's negative. We have to tell how much each sibling owes. And the hint is they share the debt equally. So we've got negative 100. Our debt is 100. And we need to share that equally between 4 people. So what kind of a number sentence do we need to write for that one, Tashana?
Could we do, I don't know, I want to say negative 100 plus 25 times 4? No? Am I
Wait
doing
a
it
second.
wrong?
Wait, hold up. It's not, the problem is negative 100 plus 25 times 4. We would have to do the multiplication first. So 25 times 4 is 100. So your number sentence winds up being negative 100 plus positive 100, and that's going to equal 0. And that doesn't really tell me how much just one of the siblings would owe. And we want an
Oh,
answer. Do you know in your brain how much will each of the kids owe?
$25.
$25. Okay. So that's a hint. And so we say that's how much they owe. So each sibling, their debt is $25. So what's the answer to our number sentence going to be? It's going to mean debt of $25.
So it'll be negative 25.
Nice job. So now we know our problem is going to start off with negative 100. And we know we're going to do something with math. And then it's going to equal negative $25 for each sibling. See if you can finish it now.
Negative 100 subtract negative 25.
Not quite.
Not quite.
Okay.
Okay.
If we're going to share, no, it's okay. You're doing great. You're really good at communicating what you're doing, and I can hear in your voice, and I can kind of imagine the wheels turning in your head. If they're sharing something equally, that's going to be a division problem. So
Oh, yeah.
what's it going to be?
It's going to be negative 25. I mean, negative 100 divided by negative 25, right?
Well, the only problem is that answer would be positive 4. And remember, we thought our answer to our problem was going to be negative 25. The answer is going to be each kid owes $25.
Okay.
So try again.
So
You're
you
super
got to divide 25 into 4, right? Because you dividing the 25 up between all 4 of them, right?
in your brain. I think you've got it. The words that are coming out of your mouth need to be tweaked, though. So we're going to start off negative 100, and then we're going to do something, and then it's going to equal negative 25.
Negative 100.
We're sharing it equally. So what's our operation? Addition,
Division.
subtraction, multiplication, or division?
Division.
Division. So it's going to be negative 100 divided by what is going to equal negative 25?
Divided by 4.
That's it. That's it. They're tricky. Okay, that's why I wanted to practice these. Let me see if I can get my slide to advance. Negative 100 divided by 4, because negative 100 is the original debt they owed to their parents, and we're going to share it equally between 4 people. So that's like dividing by 4, and you're correct. So that's the algorithm at the bottom of the page. Negative 25. And so the written answer to the problem, if they share their debt equally, they each owe their parents $25. Nice job. We'll try another one. These are very tricky. That's why these are problems I used to use with my students at school. And these were actually the test problems. They were very, very tricky. Okay, see if we can advance. There we go. Okay, this one's also difficult. Malik wants to take 4 of her friends to a movie. She knows it costs $5.50 for a ticket and $3.25 for popcorn. How much will it cost if she pays for the movie and popcorn for all 5 people? Okay, so I'm going to read that one again. Malik wants to take 4 of her friends to a movie. She knows it's going to cost $5.50 for a ticket and $3.25 for popcorn. How much will it cost if she pays for the movie and popcorn for all 5 people? Now, don't get confused. It said she's taking 4 of her friends, but Malik is going to go too. So we're taking 5 people to the movies and buying them all popcorn. And this one, Tashana, if you've got a calculator, it would be very reasonable to use a calculator to help you solve this one. So go ahead and try and solve it and let me know when you're ready to compare.
Okay, 5. Oh, shit. 50 times 5 is 27. 5 and 3. How much would it cost if she paid for movie and popcorn? 27.50. 27.50. $3.25. 27.50 plus. It'll be $43.75.
Wow, that was amazing. We're relying on my memory, but I think that's the correct answer. Let's see what I had. So let me see. For the 5 tickets, it would be 5 times by $5.50. And then in addition to that, so I need to add the cost of the popcorn, which is 5 times by $3.25. And that comes to the same thing as $27.50 plus $16.25, which is $43.75. Excellent job on the first try. And that would be, come on, advance the slide. The total cost of popcorn in a movie for all of them would be $43.75. Good job. Okay, this one, also tricky. The table below gives monthly average temperatures, and I can't see, in degrees Fahrenheit from November through March for International Falls, Minnesota. So average low temperatures for International Falls. One month it was positive 17 degrees. Next month the average was 0 degrees. Next month the average was negative 9 degrees. Next month it was negative 3 degrees. Next month the average was 10 degrees. So the question is, what is the mean of the monthly low temperatures? And you have to show your work. First of all, Tashana, do you remember what the mean is? Do you know what I'm even talking about?
Yeah, the mean is the middle number, I want to say.
Wait, say that one more time.
Mean, median, mode. Mean is the medium, hold on. Give me 1 second. I'll take you a minute.
You're awesome. Are you going through your notes? You are awesome.
I think it's in this book. Okay, the mean is the one that you do the most counting with, I guess.
That's exactly what my math teacher used to say. She said you can always remember the mean because it's really mean of me to make you do it without a calculator. So another word for the mean is the average. So you'll
Yeah.
hear both of those words. A lot of problems, it won't say what's the mean. It will say what's the average of the monthly low temperatures. So, Tashana, do you know the process to find the mean or the average of a set of numbers?
Yes.
Okay, good. These are tricky because there are some negatives and they also threw a 0 in there. So go ahead and try and solve it and then we'll compare answers.
Okay. Let me see if I remember how to do this. Oh shoot. 17 plus 0 plus -9 plus -3 plus 10. Let's see. 1, 2, 3, 4, 5. Is it 3 degrees?
Wow. Wow. Yeah, it is 3. Nice job. Okay, so see if we can advance the slide. In order to find the mean, you did it correctly. We need to add up all 5 terms. There are 2 things that usually cause problems for the students. Number 1, there's a 0 in there, and we need to include the 0, even though it's not going to change the value or the total at all. We've got some negative numbers, and you made me nervous when I heard you adding 17 plus a -9. I thought, I heard her say -8, but you did nice. When we add up all of those numbers, it comes to a total of 15. We divide by 5. Even though 0 didn't change our sum at all, it's still a value, so we're going to have to divide by 5, and the answer is +3. Well, you're on a roll. The mean or the average low temperature is 3 degrees or +3 degrees. Nice job. Okay, let's try another one. The table below gives monthly average temperatures in degrees Fahrenheit from November through March for International Falls, Minnesota. It's the same chart that we had just a minute ago. But this time, we need to tell what is the difference of the highest and lowest temperatures. And I'm going to say, I want to see you write a number sentence for this one. So I want a number sentence, and I want to know the difference of the highest and lowest temperatures. So Tashana, this is back originally, I said in those 2 packets, there were some note pages. And so for word problems to help us identify what operation to use. So this problem says, what is the difference of the highest and lowest temperatures? So what operation? Is that going to be addition, subtraction, multiplication, or division?
Subtraction.
You're awesome. Go ahead. I want to see a number sentence, and I want to see the answer that you come up with.
Okay. Table gives a monthly average of low temperatures. November to March. It's 17 plus 0 plus 7 plus -3 plus 10. 15 Will it be 12?
Not quite. What was the number sentence that you wrote?
Okay, so what I did was the table below gives a monthly average low temperatures. So I added all of them together, which I got 15. That's
Oh,
the average. Oh, wait a minute.
okay. So actually, we're answering this problem. So they want us to write a difference problem, which is subtraction of the highest and the lowest on the
Okay.
chart. So this one's
Okay.
not the mean or the average. This is a different problem.
Okay, so this is The highest is 17. 17, take away. $26.
Wow, impressive. So I know you have the correct number sentence because you have the right answer. What is the number sentence that you wrote?
17 took away -9.
You're awesome. And the thing that many students struggle with on this problem is, first of all, identifying that difference will be subtraction, but then also 17 minus -9. I can't tell you how many students look at this chart and think, oh, well, -3 is a lower number because its absolute value seems lower. But positive 17 minus the -9, we're going to add the opposite. So it's going to be like 17 plus a positive 9, rewriting it to add the opposite of -9. And the answer is 26. Did it show me? Yes. Boy, perfect. Okay. The next two are challenge problems. I debated even leaving them in, but I will say we've gotten through the lesson pretty quickly. And so we've got 2 more problems and then a little wrap up. So I'm going to let you try this one. I thought it was really confusing, but we'll give you a shot. It says the temperature changed -2 degrees per hour from noon on Tuesday until 10 a.m. the next morning. The temperature at noon on Tuesday is shown. What was the temperature at 4 p.m. on Tuesday? So let's start off. Let's even talk about what's the problem asking. The temperature changed -2 degrees per hour. So is the temperature going up or the temperature going down, Tashana?
It's going down.
It is going down. Okay. And then they throw in this information that it continued going down 2 degrees each hour from noon on Tuesday all the way until Wednesday morning at 10 a.m. Okay, so that's just information to store away in your head. They're saying now in the picture, the temperature at noon on Tuesday is shown. So at noon on Tuesday, what was the temperature, Tashana?
Let me see if I can see it.
I know, it's really small.
It looked like it says 20.
20 degrees is correct, and it's a positive 20 degrees. Okay, so now at noon, it was positive 20 degrees. The question is, what was the temperature at 4 p.m. or 4 hours later on the same day? What was the temperature? And again, on this one, I'd like you to write a number sentence and then also give me the answer. Give it a try.
At 4 p.m. So no, it's 12, 1, 2, 3, 4, 2, 4, 6, 8. So for 16.
You're really close. Started at 12 or at noon, and it was 20 degrees. And then 4 hours passed. And in each of those 4 hours, the temperature fell 2 degrees. So try it again.
Okay, let me see. 20, 15. Uh, 16. I changed. Oh, 20, 18.
Not quite.
Oh,
I'm
no,
just
no,
gonna
no.
Oh,
18.
okay. You want me to show you or not? Nope. Go ahead.
Let me see.
At 1 o'clock, it was 18 degrees. So after 1 hour, it went down to 18 degrees. Ask yourself, what was the temperature at 2 o'clock? What was the temperature at 3 o'clock? And then what was the temperature at 4 o'clock?
18. Let me see. Okay. 18. Take away 2. Let me see. Get away. Hold on, then. 1, 2, 1, 2. What am I doing? Hold on. 2.
Okay, can I butt in?
Yeah, sure. Go ahead, Brianna.
Is it 12? Like, is it subtracting or adding from the -2 degrees for the hours of it dropping?
You're right. It's dropping. It's subtracting. Brianna, can you see my thumb?
Yes.
Nice job.
Okay.
Tashana, do you see how she got 12?
Yeah, now I do it after I did it.
Oh, I get it. I totally get it. And plus, you've got Pikachu over there helping you out. Okay, so let's see here. We start with 20 degrees. And so then we say, what happens then? Like we're adding or what happens next? It's going to go down 2 degrees for 4 hours. When something happens repeatedly over time, it's going to be multiplication. It sounds like Brianna might have been using repeated addition, like -2 plus -2 plus -2 plus -2. That also works. But if you do that, if you use multiplication, it's like 20 degrees plus over 4 hours, it went down 8 degrees or it went -8 degrees. And the answer, there's our algorithm. Our answer was 12 degrees. Nice job. The temperature was 12 degrees at 4 p.m. The next one is really, really, really tough. So I'm going to help you set it up first, but then I want to see if you guys can solve it. Because the same problem, the temperature changed -2 degrees per hour from noon on Tuesday until 10 a.m. the next morning. The temperature at noon on Tuesday is shown. So the starting point is still 20 degrees. So what was the temperature at 9 a.m. on Wednesday? So now they're kind of throwing in, how does the clock work? How many hours have passed? So I'm going to help you set that one up. From 12 p.m. to get to midnight. So from noon until midnight, 12 hours passed. Then we go about 9 o'clock the next morning. So from midnight until 9 a.m., another 9 hours passed. So the first step would be to ask yourself, between noon on Tuesday and 9 on Wednesday, how many hours passed? And then you've got to say to yourself, okay, it fell 2 degrees each hour. What is the temperature at 9 a.m. on Wednesday? See if you guys can solve this one.
So do you want for Tuesday to Wednesday from 12 p.m. to 9 a.m.?
Yes, so noon on Tuesday until at 9 a.m. the next day. What was the temperature then?
Is
And
it
it's
2?
from
Say it again.
Is it 2?
No. And you know what, Brianna? Because in my brain, when I was doing it in my head, I was like, wait a second, that's a different answer than I got yesterday. You might have made the same mistake. How much time has passed? 12 hours plus 9 more hours. How much time total has passed?
9,
Well, 12 plus 9, how
but
much
12.
does that equal?
21.
21
Yeah.
hours have passed. And we know for each of those hours, the temperature went down 2 degrees. So think about the kind of problem you're going to be writing here. Think about your number sentence. We're going to start off at positive 20 degrees, and then 21 hours passed, and in each of those 21 hours, the temperature fell 2 degrees. That's our ending point. See if you can solve it now.
Sorry.
Mm. I tried to do 2 divided by 21 and 21 divided by 2, and it was 10.5. I don't know.
Brianna, and that's your issue. Let's tweak that little part right there. If it's happening repeatedly over and over and over, what operation do we use? In one of our other problems, we shared the debt equally. So we split up the debt equally and we divided. This time, we're not splitting it up into smaller parts. This time, we're doing the same thing over and over and over and over. What operation means doing the same thing over and over and over? Would that be addition, subtraction, multiplication, or division?
Is it multiplication?
Yeah, multiplication, or you could use addition, but you just have to
Yeah.
do it 21 times. But multiplication, try using that and see what you come up with.
Multiply. Okay, so it said 42. 21 times 2 is 42.
Good.
And then I multiply 20 times is 40.
Well, now wait a second. So we're at positive 20, and then the temperature fell 42 degrees. So, Brianna, you missed the beginning of the lesson where we were talking about how to deal with positive and negative integers. But our number sentence would be, let me see if I can get that to come up. Okay, screen doesn't want to advance. Our number sentence would be positive 20 degrees. And then the next thing that happens is the 22 times by negative 2, which hopefully it won't show the answer. Yay. So this is where we're at. We're at positive 20 degrees was our starting point. And then the temperature fell 42 degrees. So that's like positive 20 plus a negative 42. Donna, you still out there? Please help me solve that problem. Oh, I lost Tashana. Brianna, do you know how to solve this problem? It's kind of tricky in itself.
Positive 20 plus a negative 42. 62. It says 62.
Not quite. I'm going to show you, I think the algorithm, yay, it did, at the bottom of the screen. And if you wanted to, when Chris puts this video online, you can go back and watch the beginning to kind of catch yourself up on these rules that we came up with. It says, when we're adding two numbers and they have different signs, like this is a positive number and this is a negative number, then the answer, and I can't see the bottom of the screen, the answer is going to keep the sign of the larger absolute value. So absolute value, which number is farther from 0? So on a number line, which is farther, negative 42 or positive 20?
Negative 42.
Nice. So our answer is going to have to be a negative number. That makes sense. The temperature was 20 degrees. It fell 42 degrees. It should be negative. Okay. So now, instead of adding those two absolute values or those two terms, we subtract them. And that is so strange. That's why it's adding positive and negative numbers is one of the most difficult skills there are. So instead of adding 20 and 42, you're going to subtract them. So what's the difference between 42 and 20?
-22. It says -22.
Nice job. That's it.
So that's
So,
the answer. So
that-
you always do the opposite
You
when
want to know what? I think on the next screen, I think I've got a review. Let me make sure that that's right. Yes, the temperature was negative 20 degrees, negative 22 degrees, I'm sorry, at 9 a.m. on Wednesday. Let's look at the next screen. I think I built in a review. This is kind of a review. And you want to know what? After I turn off the recording in just a second, I can go back because there's one more algorithm or one more set of rules that is not on this screen. Okay, when we're adding numbers and we have a negative involved. So if we have a negative number involved and we're adding, if the two signs are the same, we're going to add the absolute values and keep the sign. So if we have a positive plus a positive, the answer has to be a positive, and we're just going to add the two numbers. If we have a negative and a negative being added, the answer is going to be negative, and we're just going to add those absolute values. If our signs are different, if we have a positive and a negative number, the answer is going to take the sign of the larger absolute value. That means it's going to take the sign of the number that is farther away from zero. Like in that last one, we had negative 42 and positive 20. Well, negative 42 is farther from zero, so that's why the answer was a negative. But then we're actually, when the signs are different, we're going to subtract those two absolute values, which is very confusing to our brains. You just have to practice that over and over and over. Now, when we are multiplying and dividing, the rules change, and they almost seem kind of contradictory. If the signs are the same, the answer has to be positive, and we just do our regular multiplying. So if we have a positive times a positive, the answer is going to be a positive. If we have a negative times by a negative, the answer is also going to be a positive. And that seems weird. If we're adding a negative plus a negative, answer is negative. If we're multiplying or dividing, by the way, if it's a negative times by a negative, the answer is positive. Just takes lots of practice. Multiplying and dividing, when our signs are different, whenever we have a positive and a negative, the answer is always going to be a negative. And then you just do the regular multiplying or dividing. And there is a video that I did, I think 2 weeks ago, called Adding and Subtracting Positive and Negative Numbers. It goes over all of these rules, and there's a lot of practice built in to just kind of let you practice it enough to hopefully get it into your brain. But also writing down the rules and keeping notes and using them when you're solving is a good idea too.
Mm-hmm.
There's one more rule, and it's for subtracting. When we are subtracting, the rule says you just rewrite it as adding the opposite. And so in that video from a couple of weeks ago, and also at the beginning of this video today, we did some practice. Tashana was practicing how to rewrite a subtraction problem by adding the opposite. And like I said, I'm guessing Chris will have this posted by tomorrow. But anyway, that's kind of a review of everything we did. Brianna, you did awesome.
Thank you.
You got some really tough problems there at the end. That last problem, I hadn't actually planned on doing it with students, but you guys were strong enough students that I thought, I should give you a shot, and you got it.
Thank you.